Okay, let's start with the electric field, which is 1 times 10 to the 4 newtons per coulomb, but that can also be expressed as 1 times 10 to the 4 volts per meter. So for every meter, there's a change in 10,000 volts. Distance here is 0.05 meters. We'll have a minus 200 volts at x equals 0, and then another plate at x equals 0.05 meters. The change in voltage over that distance is the electric field times the distance, which is 0.05 times 10,000, which is 500 volts. So my positive plate is at plus 300 volts. To work out the potential at x equals 20, V equals ED, 10,000 times 0.02, which is 200 volts. Let's not forget, we start off at minus 200 volts. Minus 200 plus 200, that's 0. Same for the next one. I do 10,000, this time times 0.04, which is 400 volts. We start off at minus 200 and add 400, we get 200 volts. Finally, to work out the change in potential energy when a proton moves from 40 to 20 millimeters, this is a distance of 4.02 meters, so I can work out the change in voltage. That's going to be ED once again. It gives me 200 volts, and I can work out the work, which is delta V times Q. This time the units are in electron volts. So if I write it like 200 volts times 1 electron, I get 200 electron volts. That's the work done. The proton moves from 40 to 20 on its own because it's attracted to the negative plates. The change in potential energy is negative in this case. So remember to include the negative.